Hi guys, welcome back to the channel. So we'll be discussing the bi-weekly contest, which is this is the third question, which is count the pairs of connectable servers in the weighted tree graph. So here the question seems like a bit difficult, but it is very easy. We need to focus on the main thing, which will be the intuition. So let's go through the question first, and then we'll be discussing the solution for this. So let's say we are given n servers. It will be numbered from 0 to n minus 1, and then there will be edges between uh, them, and then it will be ai, and then it will be bi, which means those are vertices, and then it is going to have the weight of weighti, and then which represents the bidirectional edge between the uh, particular tree. And then we are also given a signal speed, which which is kind of a one particular integer. And then we can say that there are two servers, which is a and b. Let's pick a, and then let's pick b. Suppose let's say there is one more server, which is c. We need to check whether a and b are connectable with c. That means this a and then this b should not be equal to c. That is the first condition. And then a should be less than b. That means this particular server should be less than b. And then we need to see one more condition, which is the distance. Let's say this is c, and then this is a, and then this is b. So the distance between this c this a and then c should be divisible by signal speed, and then the distance between b and then c should be divisible by signal speed. So that is the other two conditions. And then there is one more condition on top of this. That condition is the path from c to b and then the path from c to a do not share any edges. Suppose let's say this is a and then this is b, this is c. So there is a edge between these two, and then there is some edges between these two. So in this path there should not be any edges which is present for this path as well. So it is kind of like there should not be any common edges between these paths. That is what it is mentioned. So we need to return the count of I of length n, where count of I is the number of server pairs that can be connectable through server I. Let's say this is a server I, and there are different servers which are present, and then from this server what are the other servers which we can connect. This is a and then this is b. Can we connect between a and b? Yeah, if we can connect, then the number will increase to 1. And then let's see, there is one more pair, which is 2 and 3. If we can connect with this, then we can say there one more count is increased. So count of I represent the number of pairs that are connectable through I. That's what it is mentioned. So let's see the particular example so that we can understand better. So let's pick this example. So here we have 6 edges, 6 nodes, 6 servers, which is 0, 1, 2, 3, and then 4, and then 5. And then we are given like signal speed equal to 1. So this is a condition. So let's come to this particular server. So if we pick this particular server, can we can we make any servers which are connectable with this particular server? So let's pick this server, and then let's pick this server. So the path for this, it is going to be like this, and then the path for another server, it is going to be like, this. So these both the edges are common. So we can say that this is not a valid connectable servers. So we should not count this particular case. And then let's pick this particular path. Here also we have this common share. And then let's pick one more path, that is this one. This is also same. This shares same edge. And then let's see this path. This is also same, it shares one more edge, this one. So it is kind of like there is a common edge between all the paths, so we'll say 0. 0 is the answer. And then let's pick this particular server which we can make. So for this particular server, let's choose A as this one, and then B can be this particular path, and then this particular path, and then it can be this particular path for this server, and then one more path will be this one. So these are the 1, 2, 3. No, 1, 2, 3, and then 4. There are 4 paths which are present, and then for this particular nodes, we are going to pick one more server, that is this one, so that it will not share any edge common in between those two servers. Suppose let's say if we pick 2 and 5, then it is going to have common edge, that is this one. So we cannot pick those servers. So we are going to pick only these 4 servers, and then we are going to pick this particular server. So that will be the intuition. So let's focus on the intuition now first. So similarly we'll get the answer for this as well. So let's focus on the intuition. So for this particular path, let's say there is one node which is 1, and then there is one more node which is 2, and then let's say there is one more node which is 3, and then let's say there is one more node which is 4. This is the connectable edges between this server and then other nodes. And then let's say this is a 5, and then this is 6, and then again we have 7. Yeah, this is the diagram we had got. So focus on only this particular node. Let's say the weight between this one is 2, and then this is also 4. This is 4, and then this is 1, and then this is 3, and then this is 2, and then this is 4. Suppose let's say the signal speed is 2. Now we need to pick the elements so that the distance between those two servers will be divisible by 2. So for this particular path, for this particular edge and then path, so how many number of nodes are there so that the distance between this particular node and then other nodes will be divisible by 2? How many number of nodes are there? So this is going to be the distance between 1 and 2 will be 2. So this is divisible by 2. So we are going to say this is one count is increased, and then we'll come again here, and then the distance is 2 plus 4, which is going to be 6. So the count is increased, here it will be 1. So we'll add this 1 to here, and then 1 will be added here, and then we are going to say for this particular 2 number, it is going to be the number of nodes it can have is 2. Why? Because the number of the number of nodes which has a distance which is divisible by 2 will be 2. Why? Because all the nodes are divisible by 2. And then let's focus on the other part, which is 3 and then 6. For this particular path, the distance is 1, which is not divisible by 2. So here will not increase any count. Here we are going to say the distance between 1 and 6 is 4. So here we are going to return 1, and then this will be stored here as 1. Why? Because from here we are going to show how many number of nodes which are whose distances are divisible by 2. We are going to store that in this particular edge. So and then again we will come back here. Here the distance is 2. So here we are going to say 1, and then here the distance is 6. So this will return 1. So we are going to add here 1. So that the number of nodes present will be added here. And then let's come to the again we'll focus on the other things, which is after getting the count between the number of nodes which are whose distances are divisible by signal speed, we are going to calculate the answer. So that will be like, let's say this is 2, this is like this is 1, and then this is 2. For this particular nodes, there are two nodes which are present here. So can we connect, let's say this is the node, can we connect from here to here? No, we cannot. Why? Because the edge between here and then the path between here and then here has a common edge, this one. So we cannot connect the servers which are present in the same branch with relative to this. So we can say the nodes cannot be multiplied here, but it can be multiplied with other nodes. So let's say the total nodes is 2 plus 1 plus 2. Then we are going to say the number of nodes multiplied with these servers will be total, which is 5, and then minus the number of nodes which are present in this branch, that is going to be 2. This will be the answer for this particular case. And then for this particular case, it is going to be 1 into 5 minus 1, which is going to be 4. And then for this particular case, it is going to be 2 into 2 into 5 minus 2, which will be 3. So it is going to be 6. So 6, and then it is going to be 6, and then here it is going to be 4. So it is going to be 16. Out of these 16s, they are saying like A should be less than B. A should be less than B. That means we cannot pick A which will be like greater than B. So we should divide it by 2. So that's what we are going to do. For every node we are going to do the DFS traversal, and then we are going to store the number of nodes whose distances is divisible by 2, and then we are going to keep that count value, and then we are going to do this particular operation, which is current node into total minus current node, and then we are going to do for all this, and then we are going to do the uh, number of counts minus by 2. So let's go through the code so that we can understand better. So let's see this particular code, which contains like this is the adjacency list, and then we are going to store the signal, and then this is a answer where we'll store the number of nodes where the distances between those nodes will be divisible by signal. So let's see the implementation. So for this particular case, we are going to add all the edges which are present in this particular edges. So we are going to add in the adjacency list. It is going to be this particular node is connected to this particular node, and then this particular node connected to this particular node. So we are adding just the adjacency list with the weight, and then we are going to assign all the answers to 0, and then again we'll go back visiting every node, which is like, let's consider one node which is 0, and then for this node the distance between that particular node to itself, it is going to be 0. So that is what we are storing here. I think it's not required actually. Yeah, distance is not required, so this will not be there. And then let's see the total will return the number of nodes whose distances will be divisible by signal. So we are going to, for this particular node, we are going to traverse. So let's see that DFS traversal with the distance d equal to 0, and then this is the node, and then this is the parent. So let's see the DFS for this will be the parent, and then this will be the current node, and then this will be the distance. This will return the nodes, the number of nodes whose distances is divisible by 2, divisible by signal. So let's say the distance is 0. That means this is a particular node which from where we are going to calculate the distance. So for this we are not going to increment. And then if it is not equal to 0 and then it is divisible by signal, then we are going to increment temp plus plus. And then again we are going to see the adjacency list. If the adjacency list is like it is not equal to parent, then we are going to traverse again, and then we are going to again get back the solution of like number of nodes which are present from this. Let's say this is a node. We are going to get this one from here to here, and then again we are going to store in temp plus, and then it will be stored here. And then for this particular node, what is the answer we are going to store? This will be stored in answer. And then at last we are going to calculate for every edge. For every edge, this will be the current number of nodes, and then out of the total nodes we need to remove the nodes which are present in this particular branch, which is going to be answer of v dot first. And then again we are going to assign answers as 0, so that we can recalculate again for another case, which is for I will be moving to the next node. And then at last we are going to say we are going to return the particular vector. Yeah, that's all for this video. Thanks for watching a video. Bye.